So in the previous lessons, I discussed quadratic functions and linear functions, but overall these functions need to be translated in this lesson. And so I've listed some basic rules that you should know when translating functions. So just going back towards quadratic functions, we knew that its vertex form is y is equal to a times x minus h squared plus k, where h comma k is the vertex. And so here I have an example. So say you have 2 times x minus 3 squared plus 5. And really this is in the form of y is equal to a times x minus 8 squared plus k, which is known as the vertex form. But really, if you just look at this, it tells you some crucial things, especially how the basic quadratic function or the parent function of y is equal to x squared has really how that parent function has been moved. And so looking at this, you see this 2. This 2 means that it has been vertically stretched by a factor of 2. This 3 over here means that the parent function, has been moved 3 units to the right. And the 5 over here means that the function has been moved 5 units up. And really, if this were not x minus 3, if it was x plus 3, that would mean that the function was moved 3 units to the left. And really, just looking at this example gives us this form, which is y is equal to a times parentheses b times x minus c close parentheses plus d. And this is very important because whatever function you usually derive, it should be placed in this form to determine exactly what translations it has. And so looking at this example, usually students get confused because when you have this something like y is equal to 2 times 5x minus 3 squared minus 5, they make the assumption that this is 3 units to the right, but it's not, because you have to bring this equation into this form. And so when you do this, you have the 2, but you want to bring out the 5 so that the x remains by itself. And so when you do that, you have 5, and in parentheses you have x minus 3/5. And so really this is the form. If you bring it in this form, this is the equation you get, minus 5. And so really, just looking at this, you know that the b value is 5, as I've stated here. So if b is greater than 1, this means that there's a horizontal compression going on by a factor of 1 over b. So in this case, that would mean 1 over 5. And really what this means is that to achieve the same y value, only 1/5 of the x is required, which means that really the rate or the speed at which the function is increasing has increased even more. And so really I've made a small diagram, I guess, that you can see here. Vertical stretch corresponds to horizontal compression, and horizontal stretch corresponds to a vertical compression. And really with vertical stretch and horizontal compression, the rate is increasing. So these two types correspond to one another. So going back to this example, again, if you want to list how it has been translated and other factors, you're going to say it has been vertically stretched by a factor of 2 because of the 2 here. It has been horizontally compressed by a factor of 1 over 5. It has been shifted 3 over 5 units to the right, not 3 units, 3 over 5 units to the right. And then, of course, because there's a minus 5, the function or the parent function has been moved down 5 units. So if say b was less than 1, right, then you would say that there has been a horizontal stretch by a factor of 1b, which in essence would mean that the rate is actually decreasing. So if you had something like 1/6, and doing its reciprocal would mean 6. So that would mean to achieve the same y value, 6 times x is required, which means that the rate is actually decreasing. And overall, these are some fractions, and when you look at the b values, whether it's a fraction or it's a decimal, and you make those assumptions. But what if it's a negative value? So if a is negative, then that really means that there's a reflection across the x-axis. And if b is negative, that will mean that there's a reflection across the y-axis. So here I've listed some basic rules, especially when functions get more complicated and intricate. You want to keep these rules in mind. Thank you.